Hello kids, let's start chapter number 3 of geography, rotation and revolution. So our earth shows two motions, rotation and revolution. Let's start first with rotation. So what do you mean by rotation? The spinning of earth on its inclined axis. The spinning of earth on its inclined axis once in 24 hours from west to east. The spinning of earth on its inclined axis once in 24 hours from west to east is called as rotation. So with the help of this definition, first thing, let me tell you one thing. Rotation takes place from west to east. Rotation takes place from west to east. Rotation is completed in 23 hours, 56 minutes, 23 hours, 56 minutes, 4.09 second. But of course, we say rotation is completed in 24 hours. Rotation takes place not at a uniform speed. The speed of rotation is maximum at the equator. At equator, the speed of the rotation is maximum, which is around 1670 kilometer per hour. 1670 kilometer per hour is the speed of rotation at the equator. And as you move towards the poles, the speed of the rotation decreases. So rotation speed at equator is maximum and towards the pole the speed will decrease. Also, rotation takes place on inclined axis. Earth is always, remember one thing, Earth is always tilted. Earth is always tilted in the same direction, that is always towards the pole star. Earth is always tilted towards the same direction, that is towards North Pole. Towards North Pole. The angle at which Earth is tilted, is called as inclination of Earth's axis. Is called as inclination of Earth's axis. And from vertical, the angle of inclination is 23.5, and from orbital, the angle of inclination is 66.5. So, first, rotation takes place from west to east. Rotation takes place in 24 hours. Rotation takes place at the speed of 1670 km per hour at the equator, and this speed as you move towards the poles decreases. Rotation takes place on inclined axis. Earth is always tilted in the same direction. In which direction Earth is tilted? Towards North Pole, that is towards pole star. The angle at which Earth is tilted is called as angle of inclination. From vertical, the angle of inclination is 23.5. From orbital, the angle of inclination is 66.5 degree. These are the characteristics of rotation. So, till now, first we did what is rotation. The spinning of the earth on its axis once in 24 hours from west to east. Then 4 characteristics of rotation. One talks about time, other is about speed, other is about direction, and the last point is about the axis, tilt of the earth. These are the 4 characteristics of rotation. Now let us understand what are the effects of rotation. What are the effects of rotation? So remember one thing, because of rotation, one part of the earth will always be facing the sun. So that part will experience day and the other part will be in darkness and that part will be experiencing night. So because of rotation, first we experience day and night. We experience day and night. The part of the earth facing the sun has got day. The part which is in darkness is called as night. Also, remember one thing, the day and night occurrence doesn't take place suddenly. Suddenly, it doesn't happen from day to night and night to day. The occurrence of day and night takes place in precision and progression. It takes place in precision and progression. After the sun set, immediately we don't experience night. We experience little light after the sunset also, and that period is called as dusk. Similarly, before the sunrise, we start experiencing little light in the sky, and that period is called as dawn. That period is called as dawn. So, as I said, day and night occurrence is not sudden. It's in precision and in progression. Before night, we will experience dusk. Before sunrise, before day, we will experience dawn. During dawn and dusk, we experience little light in the sky. The light which we experience at the time of dusk is called as twilight. Remember one thing, the length of day and night is also not equal, at all the places of the earth. Okay? In fact, your place is located at what latitude and what season is being experienced in that latitude. That will decide the length of day and night. So, the length of day and night depend on 2 things. It depends on season and it depends on the location of the latitude of that place. That is why day and night length are not equal everywhere. So the first effect of rotation is it causes day and night. Then we have it causes sunrise and sunset. Sunrise and sunset. We know very well, we have done in chapter number 1, sunrise and sunset are caused because of rotation of the earth takes place from west to east. The part of the earth from darkness, as it starts moving towards light, we call that part moving towards light to be experiencing sunrise. When the part which is in light start moving towards darkness, the part which has moved towards darkness is called as to be experiencing sunset. So sunrise and sunset are also caused because of rotation, because rotation takes place from west to east. Third, because of rotation, we experience centrifugal force. Yes, again your chapter number 1 in which we spoke about the geoid shape of the earth. What was geoid? Geoid was bulging at the equator and flattened at the poles. bulging at the equator and flattened at the poles. Correct? That geoid shape is caused because of centrifugal force. And what caused this centrifugal force? High speed of rotation at the equator. So rotation causes centrifugal force, which causes geoid shape of the earth, which causes bulge at the equator. Because of rotation, all the heavenly body appear to move from east to west, because rotation takes place from west to east. So all the heavenly bodies appear to move from east to west because rotation takes place from west to east. Also, in chapter number 2, if you remember, for every 1 degree longitude, there is a time difference of 4 minutes. How did we get that 4 minutes? So if you remember, Earth is 360 degree. Earth completes one entire rotation, that is entire 360 degree, in 24 hours, which is equal to 1440 minutes. So Earth complete 360 degree is rotated in 1440 minutes, which is the duration of rotation. So 1 degree is equal to 1440 divided by 360, which gives us 4 minutes. So the time duration of 4 minutes for every 1 degree, how do we get it? Because of rotation of the earth. Because of rotation of the earth. Also, rotation of the earth also causes one more force effect called as Coriolis effect. Now, what is Coriolis effect? So, let me tell you one thing. Winds and ocean currents. Winds and ocean current. As they are moving straight, because of Coriolis effect, which is experienced near the equator. Why? Because the speed of rotation is maximum at the equator. The winds and ocean current in northern hemisphere, as they approach the equator, they will get deflected from their straight path. They will not be able to go straight. As they approach equator, they will deflect towards right in northern hemisphere, and in southern hemisphere they will deflect towards left. In northern hemisphere they will deflect towards right, that is clockwise direction. In southern hemisphere they will deflect towards left, that is anti-clockwise direction. Winds and ocean current, movement of wind and ocean current, both will get affected, and this Coriolis effect or Coriolis force is caused because of rotation of the earth. Also, because of rotation of the earth, when you combine with revolution, we experience season. And you know what? Our rotation period is not very long. Our rotation period is only 24 hours, because of which the variation of temperature between day and night is moderate, is not very extreme. The short rotational period of 24 hours is very perfect for Earth, because it keeps the temperature variation between day and night in moderation. So these are the effects of rotation. Day and night with dawn and dusk, sunrise and sunset, centrifugal force which is responsible for geoid shape of the earth, Coriolis effect. Also, all heavenly body appear to move from east to west. Time difference of 4 minutes for every 1 degree. Rotation with revolution causes season. Short rotational period causes less difference between the variation of temperature of day and night, and rotation causes Coriolis effect, that causes wind and ocean current to deflect from their straight path in northern hemisphere towards right and in southern hemisphere towards left. So these are the effects of rotation. Now let me talk about the inclined axis. As I said, our Earth's axis our earth is tilted. Correct? Our earth is tilted. The angle at which our earth is tilted is called as inclination of earth's axis. So our axis is inclined. What is the effect of inclined axis? Because axis is inclined, the duration of day and night is not equal. Because axis is inclined, we experience season. Because axis is inclined, we don't experience same temperature everywhere. Okay, now, so if axis would have been vertical, the duration of day and night would have not been equal. If axis would have been vertical, okay, if axis would have been vertical, we would have not experienced season. If axis would have been vertical, we would have experienced same temperature everywhere. If earth did not revolve on its inclined axis, there would be no season. Remember one thing, the time of the day at any place on earth is determined by the height of the sun in the sky. You remember, like afternoon we know sky is overhead. So at what height is sun? At what height of is the sun in the sky? That height will decide the time of the day at any place on earth. So these are the effects of inclined axis. See, though our earth is rotating, but have you ever experienced we don't feel this rotation? Why we don't feel this rotation? Why don't we feel any of these motions? We don't feel rotation because gravity, because of the gravitational force. And remember one thing, imagine if we would have experienced rotation or revolution, it would be so uncomfortable for us. The force of gravity keeps everything attached to earth. That is why we don't experience this motion. Gravity keeps all objects at rest. All objects are at rest with reference to the motion of the earth. So that is why we don't feel rotation. So that was all about your rotation of the earth.